In the world of language models, you constantly hear two names, BERT and GPT, and it's really easy to get them confused. They're both based on the transformer architecture, they're both massive, and they've both completely changed how we work with text. But that similarity is just on the surface. Deep down, they're built on a fundamentally different idea.
So what is that core difference? That's the one question we're going to answer today. Because while people sometimes talk about them as if they're interchangeable, their design philosophies are practically opposites. By the end of this, you'll have a really clear mental model for what makes each one tick. All right, let's get into it. The best way to understand the difference isn't to start with the architecture diagrams. It's to start with a really simple question. How do they read a sentence? Because this is where everything starts to diverge. I think the best analogy here is a detective versus a storyteller. Think about it. A detective shows up at a crime scene and looks at all the evidence at once, forward, backward, all around, to piece together the full context of what happened. A storyteller, though, moves in just one direction, always thinking about what word comes next to keep the story going.
BERT is our detective. Its entire goal is deep understanding. It reads a sentence bi-directionally. That means it looks at the words to the left and to the right of any given word, all at the same time. To figure out what bank means in I went to the riverbank, it has to see the word river. This makes it an absolute master of understanding context.
And GPT is our storyteller. It reads left to right, or unidirectionally. Its goal is completely different. It's not trying to figure out a word in the middle of a sentence. It's designed to predict the most probable next word. If you give it "the cat sat on the," GPT's whole job is to guess what follows. Mat, sofa, whatever makes sense. This approach is perfect for generating new text.
So we have our detective and our storyteller. But how do we actually train them to think in these different ways? Well, these reading styles come directly from their architecture, and more importantly, their training goals. Let's connect our intuition to a few technical details.
This table really brings it all together. You can see how the analogy maps directly to the engineering. BERT uses an encoder-only architecture. An encoder is designed to take in text and create a rich, dense representation of its meaning. GPT, on the other hand, is decoder-only. A decoder's job is to take a representation and unfold it into a sequence of new words. This naturally leads to their attention types. BERT's is bidirectional, looking everywhere at once, while GPT's is unidirectional, only looking back at what came before.
How do you train a detective? You give it a puzzle. BERT's training is called Masked Language Modeling, or MLM. It's basically a fill-in-the-blanks game. We take a sentence, we hide or mask a random word, and we ask the model to guess what it is. To get good at this, it has to look at the context on both sides of the blank. It's forced to learn context.
GPT's training, called causal language modeling, is much simpler to describe. Its job is always to predict the very next word in a sequence. That's it. By doing this over and over again on a massive dataset, it learns the statistical patterns of how language flows, making it an expert at continuing a story.
Okay, so these design differences aren't just academic curiosities. They lead to completely different tool sets, each one optimized for a very specific job. And for any practitioner, knowing which tool to grab for which task is absolutely critical.
Since BERT is our contextual detective, it shines at any task that requires a deep understanding of text that already exists. When you type something into Google Search, BERT is working behind the scenes to figure out what you really mean. It's also the go-to model for things like sentiment analysis, text classification, and pulling out specific entities like names or locations from a document.
And GPT, our storyteller, is purpose-built for generation. Its uncanny ability to predict the next word makes it the engine behind modern chatbots and conversational AI. It's used for writing articles, summarizing long documents, and even generating code. Basically, if the task is to create something new, GPT is almost certainly the right choice.
So, if you only remember one thing from this whole explainer, let it be this. BERT understands, GPT generates. That's it. That one core distinction explains everything from their architecture all the way to their real-world use cases. In the end, it's important to see these models not as competitors, but as complementary tools. BERT's deep contextual analysis is for understanding what's there. GPT's forward-looking prediction is for creating what's next. Knowing when to reach for the detective and when to reach for the storyteller, that's the key.